All right, so now we're going to be in part 2. We're going to try to get through the schematic portion of working in Altium as quickly as we can here. So we're back with just the libraries showing up on the left side there and nothing else. We haven't actually created a PCB or PWB, as I prefer, project yet. So what we're going to do is we're back in Altium, kind of like how we initially created the library somewhat of the same way. We're just going to go to new project this time. Okay, and we can give it a name. This is my Altium, my Altium tutorial. And I'll create that project. And just like last time, it's not going to default have anything in it, so we do need to add a schematic document to our source documents there. I'm going to save everything. And this, I'm actually gonna give it the same name. Actually, no, I'm not. I'm gonna do something different. I'm going to name this MCU support. Okay. And as kind of an extra little thing, in at least in the ESA MXET capstones, if you go to properties here, general, this is for the overall document. Let me expand this a little bit. Okay, so see how it says A size there? Might find you can actually make it way bigger if you go to a B size. By the way, the controls for moving around, this is true in both PCB and in schematic. Right click hold is drag. You can control zoom, so control scroll wheel rather to zoom, and then shift does a number of things for you too. Yeah, so you can do different things. I recommend Googling how to create a template. I actually have a pretty nice little template here set up. So I'd recommend looking up how to do that. We won't get into that because that's not necessary, but it was pretty straightforward, so I would recommend doing that. Okay, so I'm gonna show you a few things. So let's start with, so right there is place part. Now, you will want to get your library added to this, so we can see that boblib we made earlier is right there. I'm going to be back in my gravlib here. Now let's go put down our MSP 430. Now, so there's our part A, there's our part B. I'm actually going to save part B. I'm going to put it, actually, I do want part B on this page. I didn't plan these too well, but that's okay. I'm going to delete part A. Part B will go on this page. I'm just going to put it up here in the corner. And what I'm going to do, we can go ahead and jump right into this since this is pretty straightforward. This is power. So I'm going to go right up here to ground power port, and I'm going to place it right there. And then you can either click, I think it's place wire, or just do Control W. And we're going to tie all of these grounds together. Oops. Okay. And then if you click and hold, so you could do a VCC, you could do one of these pre-named ones. I like to just name them myself. So that says ground, but I can double click on it and change it to anything I want. I'll call it 3v3. And again, Control W. And there's that. I'm actually not going to use the output ports here. So right here, I can do a no connect. So put a no connect there and a no connect there. And then on the inputs, I can actually put if on the port thing here, I can place a port. And I'll put it right here. And I'll put another one. Whoops, not right there. That's not where I want it. I want it right there. And I'm going to name this 1. and xn2. And again, Control W. And those are basically nets. So anywhere else I make a port that has the same net name inside, those will be electrically connected without having a rat's nest all across my schematic page. Okay, so we're doing good so far. Now I'm going to go ahead and show you. We're going to add another schematic document. I'm going to name this, let's see here, or rather, save as. I will name this, I don't know, I2C, I don't know. Something, it should be something that is applicable to what's on that schematic page. I'm not going to think too hard about it right now. So go back to properties like we said. You want all your schematics to be in the same template or same, whatever you pick, make sure it's the same across all of them. Now we are going to double check that our grid is 100 mil, so that way it matches the schematic symbols we made earlier and all of our wires align with the pins we created earlier. So here we're going to place that part B. So, and I already placed my part A elsewhere, so I'll delete that. Oh, I'm sorry. We're placing the part A, aren't we? My bad. So there, we just want part A, right click to get out of that. And then, okay. And we're going to create ports for each of these. And I can just fast forward this part. I do like to kind of space them out. So, or rather, kind of alternate them. It just looks a bit better, I find. It's more readable. And then something we're going to do, just because I know it's we're using I squared C, so something we should just do is I'm going to go grab my 0603 resistor that I've created before. And you notice again, I mentioned earlier that everything's going to have a question mark. So these will have a question mark on them. And oh, I only actually needed 2 of those. And let's say that this is, let's do a 5K resistor. And you can choose to annotate these however you like. We do have requirements in our capstone on how everything should be annotated. Be sure you are following those correctly. So what I'm doing here is I'm going to pull up the I squared C lines to 3.3 volts because I happen to know that, and I can just copy this, I happen to know that that is a standard in I squared C to pull up your I squared C lines. So we're going to do that real quick. Okay, so there's 2 of our components. And okay, cool. So now I'm going to concern myself with actually creating let me just save everything, the power that'll, power everything. I'm actually going to do that on this page. So I want to create 3.3 volts. I'm going to do this perhaps a little different than you might ideally do it. A perfectly appropriate voltage regulator for this little board we're making would be, just a little low dropout, SOT 23, whatever. But for the purpose of this video, I'm actually going to show you a switching regulator because they have a weird layout, or not a weird layout, but they have a specific layout that needs to be followed for when you're doing the actual circuit card. So we're going to look at one of those. Do we really need it? No, but we're going to look at it. So I've pulled up here. You're going to look up TI Web Bench, and we'll just go into this. And okay. So we're going to say, so it's going to ask for input and output. And so we're going to tell it our input. We're actually going to end up using a barrel plug, just because that's what I want to do. So I know that it'll be 9 to 9 volts. Actually, I'm going to say 9 to 12, because why not? And my output will be 3.3 volts. And sure, why not 2 amps? We do not need that. We probably don't need more than 100 milliamps. But again, for the purpose of this video, I'm going to show you a very powerful power circuit. Even though we do not, let me make that very clear, we do not need this level of power. Okay, so let's see here. Anything under advanced that I care about? No, not really. Okay, your designs. Okay, now one thing I'm going to be, so it looks like I'm kind of zoomed in here. Let's see. That's a little better. One thing I'm going to show you that I mentioned I'd do earlier is I want to sort this by just right off the bat. I can't tell what this part looks like the main component in each of these switching regulator circuits. Yeah, a pretty good, easy way to tell it's a switching regulator circuit just by looking at it quickly. It could be a nice big inductor in the circuit and some sort of feedback resistor. And of course, you got your decoupling. So to do that, I'm going to scroll to the bottom here, click IC package, and I'm going to select, remember earlier we talked about SOT23. I'm going to select the SOT23. And do I need to say anything? No, that's a filter. So now it will only show me SOT23. And from here, it really doesn't matter. It depends on, I can look at if I have any more specific requirements than what I've already set. But like, let's just take this first one here. It has a really wide input range, 3 amp continuous output, $2 for the whole circuit. I mean, pretty good. There's a lot of options. You can just kind of scroll through and see if one happens to fit better than any of the others. Maybe you care about the price, whatever it might be. We're actually just going to look at this guy. Oh, that's not what I wanted. I wanted to look at the circuit. It'll show you a bill of materials. You may choose to use these parts. You may choose to source different parts. Just proceed with caution on that. But yeah, so this is a great tool for, and you can use it. You don't have to use this for switching regulators, by the way. It can do this for any sort of power circuit. I'm just showing you a very complex, high power one, well, relatively high power one, so that you know where to get this type of information from. Okay, I'm actually going to go steal my existing circuit from a different project I've already worked on. Okay, so I've done a number of things. So let me catch you up real quick. So let's start down here. I've created my switching regulator circuit here. We'll talk about why it's VBAT in a second, but basically this is just what I got. This might not be the same chip we looked at a second ago, but it doesn't matter. I still got this same circuit from Webbench, and it's just one I've been using for various projects. I do use a different inductor, but that's just me. It's a big chip component. You can, and if you double click on it, you can see properties, and you can go through 2D, 3D, whatever you want to look at there, just to get an idea of what you're looking at. This guy, that's a SOT23 6-pin. Again, very solderable. And these two resistors here, so you can create any output voltage you want. If you go in the data sheet for the chip and look up the formula, this voltage divider is what sets the voltage. So the VFB voltage feedback. So this voltage divider, in fact, more specifically, this resistor right here, this 10K doesn't change. This resistor right here is what sets the output voltage. So so you could take this same circuit and if you needed some goofy voltage, like 7.2 for a servo or something, you could pull it from that. Go look at the formula in the data sheet, punch your numbers in, and you should be able to get this resistor. Now, this does mean that when you're going to buy this resistor, rather than your typical 10%, 5% resistor. Maybe you want something more like 1%. It depends on how important being super close to this value is, this 3.3 or whatever it is in your case. But just keep in mind that resistor is very, very important. It determines the whole output of the circuit. But pretty much generally, and check the device's data sheet, generally everything else can stay the same. Generally. Don't count on that being the case, but pretty much the rest of the circuit can stay the same. If I wanted, say, a 5-volt circuit, I just have to change that resistor. Up here, we have our I2C device. Now, this is a super cool device everyone should know about. And it's the INA260. And this is a fantastic device. VN is going to come in from a barrel plug, and we'll look at the barrel plug here in a second. But VN comes in the barrel plug, and this device is intelligent. I've communicates over I2C, like we said. And so let's just go through the pins here. In the 3 N pluses, those are for the main voltage input. It also has a V bus. It's powered off of 3.3 volts on the VS. So this is the N plus is kind of the input, and the N minus is kind of the output. And what this chip does for you is it tells you it would be better suited on a higher power device, but it'll tell you the current voltage of, if you're using a battery per se, it might change. So it'll tell you the current voltage, it'll tell you the current being pulled, and therefore the power, it'll multiply it for you. And probably the coolest part is if you are running the system off of batteries and say they're getting too low, you can set it up to where if it reaches a certain voltage level or current level, if that's something more interesting to you, it will send an alert signal, just a digital signal on this pin 7 here, and your processor can do whatever with that information. I've decided to put that on the LED pin we created earlier. So yeah. But yeah. So it's that decoupling is very important. We always want to make sure we are decoupling power from ground. You should have a 0.1 microfarad. I use 0402. Normal people use 0603. You could even go as high as 0805. These are all sizes of chip components. But regardless of size, 0.1 microfarad on every single power pin on every single IC. Okay. These two A's are setting the address of the device per the device's data sheet. So you could have, probably 4 of these, and they could all have different addresses and not interrupt each other if that was something you needed. Now let's talk about the barrel plug. So this is the barrel plug in question. It's a very typical, let's see, where's a good picture? It's a very typical barrel plug. It has these kind of square pins to it. And the problem is you could make this, you could certainly make this footprint. The problem is it's kind of weird. You have to get the spacing right. Stuff like that. So I find that it's easier for some component, and this is especially true of, like, I had to use Ethernet, like an RJ45 jack or an SD card footprint. I would so if you go in any of your libraries, scroll all the way to the bottom, need more components, try manufacturer part search, click that. And I'm going to type that model number back in. And there's my little friend there. And because everything's green here, I can drag it over and it shows up in my schematic. And so there's that. And we do get a footprint for it. So that's pretty cool. Now, I wouldn't count on those 100% working every single time, but it's usually pretty safe, and we can always do that paper test. You can always do a paper test with connectors. So I'm going to tie both pins 2 and 3 to ground. One of them doesn't really do anything, and the other actually is ground. And then pin 1 is going to be our main input, and it's going to be V in. So I'm just gonna. I'm sorry, I'm not making this terribly pretty at the moment. Now, something I'm going to add to this, just kind of to show you, is I'm going to add a test point right there. And test points are very important. In fact, we're going to have four more of them. And we're going to tie them all to ground. You need at least 4 ground test points. And these are important because you need to be able to, this is a very hideous way to do this. You need to be able to access ground very easily when you're doing testing on your board later. Now, these test points, I've created the footprint for these. You can find these. They're just surface mount solderable little disc things that you can fit oscilloscope probes through. And yeah, pretty straightforward, really easy to make the footprint. Just look up find one and get a dash sheet for it. Okay. So I think we've got power. We've got stuff laid out here. I'm going to need some crystals. I'm going to use some crystals I already have. Probably not technically the right things, but that's okay. Use your reference. Use reference designs extensively. They are invaluable. And when you're talking about them, you can just say, this is reference design from this. And I have validated that reference design myself and know that it works. Okay, I don't know why I named this I squared C. I have this all mixed up. There are far better ways to arrange all this, but we're kind of already here. This schematic really did not need to be 2 pages, but I wanted to show everyone 2 things. 1, how to make a 2-part component, and 2, how to do multiple schematics in a single PCB. Both of these are important. Okay, so now we're going to do our decoupling. And decoupling, again, look at your reference designs. Go off of the reference designs and do not necessarily go off what I do here. However, I will say, earlier I said you need one of these for every power pin. Well, 1, 2, 3, 1, 2, 3, right? So that takes care of those. And then they'll usually have some bigger capacitors that go around the chip to further help decouple. So be sure you just check that. Just look at your reference design, whatever chip you're using. I'm sure you have a development board for it. Find the schematic for it, figure out what parts they use, and go off of that. It's very important that you look at your reference design. Okay, do we have anything else we need to add? You know what? I am going to add one more thing. So, okay, I've also decided to add a low side switched LED, still on that same LED port. I know it's our interrupt port at this point, but you know, we could use this as a visual alert to something that the INA 260 is trying to tell us. I've used here the BSS 138. And we are able to just low side switch it. And yeah, low side switching is always good because then you don't have to rely on your microcontroller to provide the current to drive the LED. You can do very little current and drive the BSS 130 or just an in-channel FET in general. And this is also a SOT 23. In this case, it's a 3-pin. Okay, the last thing we actually need, I think, is we need a header for our all of our programming ports. So we need one 2, 3, 4, 5, 6. We need a 6-pin header. Now there's a fantastic library already in here, miscellaneous connectors. And then if I scroll down to header 6, I'm going to hit the space bar twice. This header, this is a hideous schematic. This header is the same header like what you would find, like it's breadboard spacing. They're each 100 mil apart, or was it 2.54 millimeter, something like that. And so yeah, so you can fit normal pin headers in the ones that it says header. And I'm just gonna move all these over. And you could of course make these headers. I'm just showing you for the sake of time. Just that one. We can add labels to things. I just clicked on the little A here, and I can say this is a user LED. I can label this section. I can say this is my JTAG here. I can say that these are I2C pull-ups, just things like that. Okay. And again, in the capstone stuff, there is specific ways you're supposed to go through a checklist for the schematic. Make sure you've met certain requirements. Here I've shown you very basic ways to do things. You absolutely should format it better than this. And this board does not need 2 pages of schematics, but for the sake of the video, it has 2 pages of schematics. So we're going to do a few final things. I've clicked on tools here. I mentioned in part 1 annotating schematics. So we're going to click that. A window will pop up. And you can do this more than once. I just like to do it when I'm done if I can. And I'm going to update my change list. 29 changes. Okay. Accept them. Validate them. Execute them. Close. Close. And so now everybody has P1, R1, R2, U1, all that good stuff. We can go here to U2. Great. This is also U1. It knows that's the same part. So yeah, so that's looking pretty good. We're going to save everything, and as a preemptive for the next part, I have a bunch of other projects open now. Close. As a preemptive for the next part, we're going to go ahead and compile this project. And whatever dialog pops up, it's okay. Okay. Looking good. All right, I guess that's the end of part 2. Next one we'll make, I don't think I've forgotten anything. Again, there's ways to make this all prettier. But yeah. Oh, I have to add crystals. I'll do that in a minute. Yeah, be sure you add those. And those be sure to look in crystal data sheets for the kinds of capacitors they need around them and things like that. Be sure to check that. Okay, I guess that is it for this one.